beautifully. And the motivation is 2 pi by n we can assume to be some angle theta. It feels as if a circle is magically divided into n equal parts. And then what's the significance of this angle? So it's like cos k theta. We have sine k theta. Then cos k plus 1 theta. And we got sine k plus 1 theta. So that of these expression. And that evaluates to cos k theta into sin k plus 1 theta minus cos k plus 1 theta into sin k plus 1 theta. Now we are trying to see the geometrical meaning of this determinant. And we know if we have any at ABCD, its value is AD minus BC. Beautifully, this determinant can be thought as area of parallelogram in geometry. So let's take, if I treat the first row as vector A comma B, and we treat the second row as another point C comma D. So area of parallelogram having adjacent sides at vector AB and CD gives exactly in magnitude AD minus BC. You can also do the other way around. If we'll take the first column as a vector, let's say AC, and then other column as another vector B comma D. So if I'll calculate the area for this parallelogram, which is not very difficult to find, either you can do using coordinate geometry, AB into cos theta, or using, actually you can do using coordinate geometry, AB into sin theta, or you can do even with vector calculus. Or so it's the area calculation, improving it is not very difficult because you can just take these 2 points. So using area of a parallelogram, half into AB sin theta into 2 will give area of these two triangles, and which amounts to AD minus BC in magnitude. Okay, so we are going to use this special idea. So let's say if theta equals 2 pi by n, by definition, it means we are dividing this circle into n equal chunks. We are dividing this circle into n equal parts. Now what is the significance of this determinant geometrically? It represents area of parallelogram having cos k theta, sin k theta as one of the vector, and cos k plus 1 theta and sin k plus 1 theta as another vector. So let's try to plot this. For theta equals 0, clearly we'll have 1 comma 0 is the first point. So we'll have parallelogram containing vector 1 comma 0. And for theta equals, okay, so let's try to geometrically fill it. For k equals 0, as it's running from k equals 0 to n minus 1. So for k equals 0, we will have 1 comma 0 as first point of the parallelogram, and the other point that we are going to get is cos theta comma sin theta. So it's directly is a vector at an angle of theta. So this point is cos theta comma sin theta. Now the value of determinant is nothing but the area of the parallelogram formed by this. So let me color this by red chunks. Now if I take k equals 1, we'll get another parallelogram, because now for k equals 1 we have one point is cos theta sin theta, and you can clearly see the other point is cos 2 theta sin 2 theta, which is again at a theta angle inclined to the final vector of the initial configuration. So we'll draw another chunk, another parallelogram, and we'll have this area for k equals 1. Similarly for k equals 2, we'll get another parallelogram and we'll calculate this area, so on and so forth. Now you can clearly see in the limiting case, when k equals n minus 1, we'll get exactly parallelogram over here. So we'll have the parallelogram over this and this area. So we need to add area of all these wings, right? We have to add area of all these parallelograms. Now as n tends to infinity, we can clearly see as n tends to infinity, since the parallelogram slice will become very small because this theta angle is very small. So I can imagine the length of this arc is almost same as the straight line, right? So in that case, the area of sector is same as area of this triangle in the limiting case when n tends to infinity. What I mean is when n is very large. So what's the area of this parallelogram? Let's call that is delta. Then the area of this small arc will be delta 1. Similarly, area of other segment will be delta 2. The area of other half segment will be delta 3. And now it's no wonder if we'll add all the area, delta 1 plus delta 2 till delta n minus 1 when n is very large, so till infinity, we are going to get nothing but area of this entire circle. So area is pi into 1 square, which is pi. But that's not the answer, because pi is the area of this half triangle summation. We want area of this entire parallelogram. So since these two triangles are exactly having same area because of congruency or symmetricity, hence the answer to our problem is 2 pi. इस क्वेश्चन को हम सिंपल में भी सॉल्व कर सकते हैं बिना ज्योमेट्री के सॉल्यूशंस के, और लेट्स ट्राई टू सॉल्व दिस विद मेथड 2. तो अगर मैं डिटरमिनेंट को सिंपली एक्सप्लेन करूँ, सो इट्स कॉस ए साइन बी माइनस साइन ए कॉस बी 2 पाई के बाई एन इंटू कॉस 2 पाई बाई एन के प्लस 1. और ये साइन ए कॉस ए साइन बी के फार्मूला से इट्स लाइक साइन ए कॉस माइनस कॉस ए साइन बी, सो इट्स साइन ए माइनस बी, सो विल गेट 2 पाई के बाई एन प्लस 2 पाई बाई एन माइनस 2 पाई के बाई. So that is nothing but simply sine 2 pi by n, and now sigma sine 2 pi by n from n for k equals, so that is nothing as sigma 2 pi by n. Now from k equal to 0 to n minus 1, limit n tends to infinity, same as sine 2 pi by n plus sine 2 pi by n. क्योंकि k is absent in the picture, तो अगर k 0 देंगे तो यही टर्म आएगा, k 1 पे भी सेम टर्म आएगा, k n minus 1, so this will go n minus 1 times, so we have n minus 1 sine 2 pi by n. Now you have to make n really large, so under the condition when n is really large, you can basically find the limit of this expression by dividing by 2 pi by n and multiplying with 2 pi by n. Now when n is very large, this will almost be tending to 0, and hence sine of something is tending to 0. And clearly you can see from sin x graph, as x is tending to 0, sin x behavior will be almost similar to x. Hence sin by x will behave like 1. So this quantity goes to 1, and n minus 1 2 pi by n is our answer when n is infinite. Now when n is infinity, again you can divide it by n, so 1 minus 1 by n. 1 by n will almost be tending to 0, so the limit is still 2 pi. So you see how geometrically and algebraically हमने इसको solve किया. So the takeaway was question was simple, but how someone can translate the information